guys, so today we're looking at 3D trigonometry. Our learning intention for today is to be able to solve 3D diagrams using trigonometry. In all of these questions, the main thing you have to remember is if you see a 3D trigonometry, think, draw a 2D diagram. You will find that making quick sketches as you work will help you visualize what to do. So in these questions, always draw out a diagram as well. Okay, let's look at an example question. We're given a cuboid as shown, and we're asked to calculate the length of BD. And in part B, we're then asked to calculate the angle between BH and the base of the cuboid. Okay, the first thing we're going to do here is highlight the length that we're trying to find. BD is this diagonal length here. We can find the length of BD simply by using the base. When you've highlighted the length that you want to find, draw a right angle triangle. Here we can see D to A and A to B form a right angle triangle. Let's draw this out separately and label our sides. We can see that A to B is 7 centimeters and A to D is 4 centimeters. This is the same as our opposite side here, BC. Now we simply want to find our unknown. This is a right angle triangle, so we're going to use Pythagoras' theorem. Let's write down Pythagoras' theorem and label our sides. Our hypotenuse is always C. Label A and B as the other two sides. From here, substitute the values that we know into Pythagoras' theorem and solve. This gives us 7 squared plus 4 squared equals C squared. Solving this out gives us 65 equals C squared. Square root both sides of your equation, and C is equal to 8.06. Anytime that you're looking at a 3D diagram, draw it as a 2D shape. Most of the time, you'll be looking at a right angle triangle. So in this case, we're going to be using Pythagoras, or sock, cat, and toa. Okay, let's look at part B. Calculate the angle between BH and the base of the cuboid. Let's have a look at what we're looking for. To find the angle between BH and the base, draw on BH and look to see if you can make this a right angle triangle. Okay, let's draw our length from B to H. How can I make this a right angle triangle? Draw a line from H to D, and then another from D to B. Here we have our right angle triangle. Draw it out separately. Label your sides and write in the lengths that you know. We are looking for the angle between BH and the base. Let's call it theta. We know that the distance from H to D is 6 centimeters, as it is the same as the distance from E to A. And we find in the previous question that the distance from D to B was root 65. Okay, let's try and find our angle. To do this, we first need to label our sides. The side opposite the given angle, or the angle that we're trying to find, is labelled the opposite side. The side opposite the right angle is our hypotenuse, and the adjacent is the other side. We have a right angle triangle, so we're going to use sa, ka, toa. Okay, we want the angle and we have the adjacent side and the opposite side. Therefore, we're going to use toa. This means that tan of our angle is equal to our opposite over our adjacent. Let's substitute in what we know and solve. Tan of our angle is equal to 6 over root 65. To find theta, we first calculate 6 over root 65, which gives us 0.744 recurring. And now, to find our angle, we inverse tan 0.744, and we get an angle of 36.7. Let's look at another example. Remember, when you're dealing with 3D diagrams, you need to find the 2D shape. And generally, we want a 2D shape that will form a right-angled triangle. From here, you'll use Pythagoras if you have two sides and you want a third side. Or if you're given an angle or want an angle, you'll use sa, ka, toa. Okay, let's look at the more difficult example. The Great Pyramid is a square base pyramid of side length 230 meters and is 130 meters high, 39 meters high. If you were to stand in one corner and walk to the top, what angle would you be walking at and how far would you have to walk? You're also given this diagram. Okay, so we want an angle and we want our slope of how far you're going to walk and the angle of that slope that you're walking up. Remember, if you have a 3D shape, you need to draw a 2D diagram. And look out for your right angle. Okay, so what can we find? We know that the height is equal to 139. We need to find the diagonal first before we can find our angle and our slope. Okay, how can we find this diagonal? We have a right angle triangle with the diagonal and the two bases, which are 230 meters. Let's draw our right angle triangle and solve for that diagonal base. This is a right angle triangle, so again we use Pythagoras' theorem. Let's label our sides. C is the hypotenuse, A and B are our other sides. Substituting our values into our equation gives us 230 squared plus 230 squared equals C squared. Adding up these values gives us 105,800 equals C squared. Square root in our value and we get C as 325.27. This is the diagonal length. Remember, we're trying to find the slope here, and we know this height in the middle. To find our slope, I am going to halve my diagonal. This gives us the distance from the center of my base to the corner as 162.63. From here, we can see our right angle triangle. Drawing it out, we have a height of 139 and we have our base as 162.63. To find the angle, we'll use SOHCAHTOA. Labeling our triangle, we have our hypotenuse. Our opposite side is the side opposite the angle we want to find, and we have our adjacent. To find our angle, we have the adjacent, we have the opposite, therefore we will use tan. Tan of our angle is equal to our opposite over our adjacent. This gives us tan of our angle is equal to 139 over 162.63. To find our angle, we inverse tan. 139 over 162.63. Substituting this into our calculator and we get an angle of 40.5 degrees. Okay, let's look at the second part of the question. We want how far you have to walk. So we are looking for the slope. Here we're going to use Pythagoras' theorem. Okay, let's label this triangle. C is our hypotenuse, A and B are the other two sides. Let's write down Pythagoras' theorem. A squared plus B squared equals C squared. Substituting in what we know gives us 162.63 squared plus 139 squared equals C squared. Adding these up, we get 45,771 is equal to C squared. Square root our value, and we get C as 213.9. So to get to the top of the Great Pyramid, we have to walk 213.9. So remember, with three-dimensional problems, it is important to identify the right angles in the question. Then redraw these right angles and use the appropriate ratios or Pythagoras' theorem to solve them. If you see a 3D shape, think 2D diagram. Find your right angle, triangles, and solve with Pythagoras or your trigonometric ratios, SOH, CAH, and TOA. Okay guys, now that you've seen how to look at and solve 3D diagrams, let's try a few questions. In your books, I want you to turn to exercise 7.10. Please complete questions 1, 2, 4, 7, 8 as your challenge.